Hello and welcome to the course again. Today we will be discussing about understanding the hardness of water. What causes the hardness of water? What are the minerals that are responsible for hardness? What are the types of hardness and how to remove the hardness of water? We will discuss these details in today's class. So this hardness of water is basically caused by the presence of calcium and magnesium minerals in water. This is originated as water permeates through the mineral-rich geological formations such as limestones, chalk, and gypsum. So it is formed in the underground water. It can be formed in the river water or flowing water also. So due to the presence of these minerals, the water becomes hard, and when the hardness is much higher, it is difficult to use the hard water for industrial purposes or for domestic applications. Let us understand the things in much more details. So measuring and classifying the hardness of water. Hardness of water can be classified into various types, whether the hardness is very hard or it is a moderate range or it is hard or it is a soft range. Soft range water generally we can use for our domestic applications and also for the industrial applications. The hardness is generally measured in the units of ppm, that is parts per million. So these parts per million, these are the units of hardness. So these are measured in the unit called ppm, that is parts per million. How much milligrams of this calcium and magnesium salts are present in liter of water, that is reflected as a ppm. So this ppm, if it is around 60 to 75 ppm, or we can say if it is below 75 ppm, then the water is called as a soft water and it is well for our drinking, it is healthy for our drinking. And also for various industrial applications, like it can be used for the power producing industries like these power plants, thermal power plants. It can be used in boilers and other industrial applications where water is used as a coolant. However, if the hardness is slightly higher, it is 60 to 150 ppm, then we call that moderately hard water. This water is also healthy for drinking. There is no harm for our daily usage or domestic applications. Generally, if the hardness is much higher, then it is difficult to wash our clothes using this hard water, because hardness is generally termed as the soap consuming capacity of water. What happens is, when the soap, that is sodium or potassium salt or fatty acid, reacts with these salts like calcium or magnesium, then it forms magnesium or calcium salt of fatty acid. Those calcium and magnesium salt of fatty acid, when it goes to the water, it is insoluble in water, then it consumes the soap. That's why the term is known as soap consuming capacity of water, is called as hardness. So if the hardness is around 60 to 150 ppm, then we term this as moderate hardness. If it is higher than that, if it is 150 to 300 ppm that we find in our underground waters like tube wells or bore wells, so we say that as hard water. This hard water is also not useful for our domestic applications. We cannot use this hard water for our washing or even cooking or boiling. So if we are boiling this hard water, then it forms scale forms. Okay. If the hardness is higher than this 150 to 300, or it is more than 300 ppm, then we say it as a very hard water. In this hard water and then very hard water, this hardness needs to be removed to bring it back to either moderately hard or soft water. Soft water, for industrial applications, we need softness below 60 to 75 ppm. Sometimes it is the requirement is around 10 to 15 ppm. We will discuss how to do that. So the hardness is divided into two parts. One is temporary hardness, another is the permanent hardness. Temporary hardness is a temporary term, or we can say it can be easily removed. That's why it is called as temporary hardness, or sometimes this hardness is also called as bicarbonate hardness. This temporary hardness is caused due to the presence of calcium and magnesium bicarbonates. When this calcium and magnesium bicarbonate salts are present in water, so they cause this temporary hardness. However, when we boil the water containing temporary hardness, in that case, the hardness can be easily removed, or we can form soft water. The equation is as follows: Ca, suppose CaHCO3, that is calcium bicarbonate. Calcium bicarbonate, CaHCO3 whole twice. When it is heated, it generates calcium carbonate plus CO2 plus water. So this calcium bicarbonate, when it is formed, it is insoluble in water, and then it can be precipitated out immediately. Similarly, if you have magnesium bicarbonate, if you heat this, then it forms magnesium hydroxide plus water. So magnesium hydroxide plus carbon dioxide. In these two cases, if you are heating, then this salts form, that is calcium carbonate and magnesium hydroxide. These salt precipitate out, and then after boiling, your water will be free from calcium and magnesium. You can see if you are boiling the water in a pan or in any pot. So after boiling, you will see this salt will be deposited on the bottom of the kettle or a pan, whatever you are using. So by this way, you can remove the temporary hardness. However, the permanent hardness cannot be removed by simple boiling. This permanent hardness is caused due to the presence of salts like calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These salts, when present in water, they cause the permanent hardness. So this permanent hardness cannot be removed by simple boiling. This permanent hardness retains in the water even after boiling, and it requires chemical softening treatments such as lime soda process, zeolite process, ion exchange process, or reverse osmosis process. So effects of this hardness on health and benefit. What are the benefits also? So if the water is hard, then it is not considered as a health risk. It can contribute to your daily intake of essential minerals like calcium and magnesium. So it is estimated that moderately hard water might contain approximately 50 to 70 milligram of calcium. So that we can use in our daily day routine, or we can drink it without any health issues. The World Health Organization has noticed that potential cardiovascular benefits associated with the minerals found in hard water. However, individuals on low sodium diets found to be mindful that some of the water softener replaces the hardness minerals with sodium ions, potentially increasing sodium intake. Like as I told you, the zeolite process and the uh, lime soda process, both of the two things may increase the sodium intake in the body. Then, household and industrial impacts of this hard water. What are the impact of this hard water? So, first thing is formation of uh, this unslightly soap on the surface, soap serum on the surface, reduced lathering of the soaps and detergent, gray or dull staining on the clothes after washing, spotting of dishes and glasswares. If you are using the hard water, then these things can happen. The lathering process will be decreased of the soaps or detergents will be decreased, and then spots will be formed on the glasswares or appliances that you are using. So if regularly these are used, what will be the damage caused on the appliances? So scale build up inside the pipes and boilers and water heaters will happen. Reduce heating efficiency due to the mineral deposit, and sometimes the pipeline that are used, they can be also clogged, and then the lifespan of these appliances will be reduced also. Industrial costs, significant expenses for scale removal in the uh, bigger industry, mostly in the cooling pipelines, increased energy consumption due to inefficient heat exchangers. After this scale is formed inside the heat exchanger pipes, then their efficiency decreases. Then higher maintenance and replacement cost of the machinery also increases. So how can test the hardness of water? So we can test the hardness of water by different ways. One of the simple ways is visual sign. Look for a tentacle signs like lime scale deposits on the uh, figures, and then if some spots are formed on the dishes, and excessive soap residue on the skin or clothes, and then some other tests are there, but however we will mostly follow these lab tests. So in lab we will use EDTA method, one of the best test methods. We will use EDTA, ethylene diamine tetraesteric acid, and as a complexing agent, and we will do the complexometric titration, and we will find out what is the hardness of water. So treatment, what are the treatment processes? As I told you, the treatment processes vary depending upon the applications, and depending upon where it can be used, what is the label of hardness, and what are the minerals present along with this hardness causing minerals. So one of the easiest method is the lime soda softening method, where this lime, calcium oxide, and soda, that is sodium carbonate, is added to the water, and these react with the water, and this calcium and magnesium ions are removed by forming calcium carbonate and magnesium hydroxide respectively. So this calcium carbonate and magnesium hydroxide will be removed by filtering, by using any sand filter or any